Who would have thought that kimchi might potentially be a very powerful tool in the plastic pollution crisis? At least the plastic in which you consume. Now, in this particular study, they used polystyrene nanoplastics, some similar to what you eat in the real world. And you go, well, I don't eat plastic. Well, the average individual through diet and so on and so forth consumes about 5 grams of plastic per week. And that's about the size of snacking on a credit card. All right, so in short, what we have here is this. We have the comparison of two forms of beneficial bacteria. We have Leuconostoc, Meneteroides, and Lactobacillus sakei. Now, the interesting part about this is this. All right, you notice the two green bars there are pretty solid. But what happened was, one is in vitro. So the Lactobacillus sakei, basically looks really good in a test tube, lab conditions. But when compared to, how would you say, the human intestinal tract, what you have here is Leuconostoc Meneteroides being the rising star in regard to absorbing or sticking to, I should say, these polystyrene nanoplastics. And Lactobacillus sakei, not so good. Only about a 3% binding effect compared to 57% in basically, how would you say, a simulation of the human intestinal tract itself. Because the stomach acid's part of it. Now, the interesting part about it is, too, so the Leuconostoc Meneteroides has like an armor that protects itself against the stomach acids fairly effectively while maintaining that stickiness. Well, without further ado, let's get right into the study itself. You're going to find kimchi to be quite amazing. All right, to start, an ancient cure for modern crisis. Biosponge is probably the understatement there, but you can see right there as far as the effect and how it's entirely natural and has been basically in front of us or underneath us, however you want to put it, for quite some time historically. What an incredible tool. And then you look at this. This is, I want to give you an idea. Who would have thunk shellfish being one of the primary food? Well, obviously, after here, you could draw the connection. Plastics, oceans, so on and so forth. And then you consume the wildlife which exists in that environment. And boom, boom, the cycle of plastic waste. So the trick is we want to get it out of the system. So let's go right into the study now itself. Kimchi-derived probiotic found to promote binding and excretion of intestinal nanoplastics. I'm going to run through it real fast, and then we're going to go more to the graphics, a little bit more detail. So please forgive me if I speak kind of fast, but here we go. Understanding laboratory conditions, Leuconostoc Meneteroides, in this case, strain CBEA 3656, if you want to remember that, like a license plate, showed a high absorption rate of 87% comparable to that of the reference strain Lactobacillus sakei, about 85%. However, a notable difference was observed on the simulated human intestinal conditions, as we showed before in the prior chart. Basically, while the absorption rate of the strains, basically the Lactobacillus sakei, CBA 3608, decreased sharply to 3%, while the Leuconostoc Meneteroides, you got the strain, maintains a sustainable high absorption rate of 57% in human intestinal tract conditions. In the animal study, it actually went way up. These results indicate that the kimchi-derived strain can stably bind nanoplastics even in environments resembling the human intestinal tract. Strong plus. Significant findings were also observed in animal experiments using a germ-free mouse model. Compared to those in the control group that did not receive the probiotic, both male and female mice administered this strain, Leuconostoc Meneteroides, part of the kimchi, showed a more than twofold, they're both part of the kimchi, but that particular strain is important, showed more than a twofold increase in nanoplastic detected in the feces. This result suggests that the probiotic may contribute to the excretion of nanoplastics by binding to them in the intestine. So we don't really work at a body surface area here if we're trying to draw a human correlation. We're looking more at a gastrointestinal tract volume thing, which we'll get into that math in a second too. The study provides scientific evidence that kimchi-derived lactic acid bacteria may interact with environmental micropollutants beyond their traditional role in fermentation. The findings provide a new insight into potential biological mechanisms that may help reduce nanoplastic accumulation in the gastrointestinal tract. All right, here we go. The target mass, we're looking right there, the GA tract volume capacity as opposed to the body surface area, works out to be about 100 grams per day to postulate. Again, there's a lot of factors involved, but going from animal to true living world human conditions. All right, so that's pretty good. And then we move forward, the pin board. So basically it has a biosynth effect, and then it basically works through binding to it, survives the stomach gas because this leuconostic metatoroides has like this armor. So basically it survives the stomach acids, makes the intestinal tract sticky, sticks to the plastic like a biosponge, this polystyrene nanoplastic, and then boom, out the system it goes. Real important, especially these days. And thenceforth mitigates part of the damage of consuming about the equivalent of a credit card worth of plastic in that way every week. All right, and there's the recipe too. So looking at it from basically a food prep area, interesting thing here too. Notice, do not use ionized salt. Even though the salt did have antibacterial effects on its own, the iodized salt, the iodine particularly just basically wipes the whole thing clean. Not good, great for wounds and things like that, not part of your kimchi fermentation program. And there's basically the idea, the prep that they would utilize in regard to the Napa cabbage, so on and so forth, the freezing, the oxygen deprivation, so on and so forth, and boom, you have literally a superfood. All right, now we're going to go into the data portion of it for the healthcare provider. And so here we go, the provider playbook. This is where you're looking at it, for example, you're looking at dysbiosis, GI inflammation, or impaired motility, which could be partly contributed to, again, causal and correlation, two different things, correlated to a stomach full of plastic. Gross, but yes, that's the point there. And here we go further into it. The architect of the study in this animal trial was basically an A-. They went 10 more mice than necessary, so they did pretty good. The p-value for certainty without looking at the confidence interval is pretty darn promising as well. You see there. All right. The contenders. All right, the CBA 3656 is obviously the leuconostic metatoroides, and the CBA 3608 is the Lactobacillus sakei. So there you have the two forms right there, and it's sticky outy armor, like a belly button. All right, well, you get the point. It's real important because it's armor and it's sticky, and boom, polystyrene nanoplastic, bye-bye. You want to go into detailed explanation of it. There you have the APR excretion, the cell wall and the binding trap, so on and so forth, and the GO motility transit. Well, that's pretty self-explanatory. And then the animal trial, of course, right here, is when you see 100% in the prior slide or block, means it's basically double that of generally the other aspects, for example, of these germ-free mice. Now we get into the detail for basically study replication for those still with me or with us. And here we go. The quantifying method, the math utilized in the particular study. If you're really, it's actually kind of easy math. It looks cool there, but it's easy. All right, budget allocation. There you have it. Looking at about $285,000. I'm always interested when the researchers chime in and say, hey, you're pretty close to your estimation on the clinical research trial cost. So $285,000 basically discover that kimchi can save people who knows how much untold heartache or stomach ache in this case in regard to helping excrete those nanoplastic out of the system, especially children. This cuisine, this kimchi, is then being a powerful tool, although be it ancient, is perfect for modern time, especially in these sterile environments. All right, replication blueprint minus the plastic. All right, there you have it as far as you want to reproduce a study. There you have your 4 blocks. The bacterial gavage, you see the whole lineup here, how it's basically kind of like right to the stomach, right to the point. Kimchi matrix, the kimchi matrix, not to be associated with anything else. There's your substrate prep, your fermented kinetics, and your strain isolation. I'll leave it there. By the way, all these info charts or infographics I have on clinicalnews.org, so you can review it on your own. So it's not like it's here, then gone tomorrow. Go to clinicalnews.org, and you'll find it under the study, the infographics. I just take an iframe and throw it in there, and boom, The infographics are there. And the scientific dictionary for any part that was tough to understand, which often is quite a bit, but still just the same. There's a little bit of breakdown of the most pertinent aspects, vitro, vivo, people need to see that, the strain, so on and so forth, and what germ-free model means. And so there you have it, quite an interesting solution to a modern day problem, or in case they word, an ancient food for potentially a modern day. Don't want to use the word cure, because again, how do you cure someone from consuming plastics on a daily basis unless you get the plastic out of there? Are you really curing it, or are you cleaning it up? And in this case, kimchi tends to help as a powerful cleaning tool. In this case, you may have seen it in some of the wording, to detoxify those polystyrene nanoplastics out of the gut, and which, when you look at the damage that the microplastics do, you really want to look at kimchi again and go, doesn't look so, actually look more and more appetizing as time goes on, because I do love kimchi. All right, gratitude for the researchers. Again, this takes money and time, and they put themselves to it and put it to the test and found out what aspects of the kimchi actually have that sticky binding biosponge effect to pull these polystyrene nanoplastics out of the system and away from you. And so there you have it. Gratitude to the researchers. I am humble you watch and see what you and I discover next week and try to explain it all with under 10 minutes. All right, catch you all next time. See you then. Bye.